this video will cover section 10.2 arithmetic sequences. And if you are watching this video, Anna, I'm going to throw a question in there later. And if you answer it, I might give you some extra credit on your test, which is this Wednesday. Also, you could get 10 points by completing the review and a point by turning in a plastic empty container. If you need more information, ask your classmates. So we're going to test if you watch this video. All right. So first problem, introduction, which we're going to solve with the last slide. Okay. It talks about a grandmother and her financial counselor. We're looking at options for an adult residential facility, which is very pricey in the U.S. And the good news is that the grandmother had already $500,000 saved. The bad news is that the cost, and this was back in like 2009, I think, or 7, I don't remember. The cost was $64,130 annually. And so if you think about it, that's more than a teacher's salary. Like, so pretty pricey. And the cost is increasing $1,800 per year. So with this type of arithmetic sequences, we're actually going to relate them to linear functions, and I'll show you why in a minute. Well, we can see with that, if it increases $1,800 each year, there's a constant rate of change. So we add $1,800 every year, $1,800 plus $1,800 plus $1,800. And so that's why one of the reasons we can relate it to a linear function. So that problem is going to come up again on that slide, and we're going to have to figure out if that would be enough for the grandma to live there for 6 years. Someone asked me in the period before, why only 6 years? Is she expected to die in 6 years? We don't know. Okay, that's just a question. So, and then I'll tell you a very interesting story for your future, for when you are at that age. I'll give you a better option than a nursing home. I'm not going to tell you. Okay, so let's just talk a little bit more about arithmetic sequences. So that other one that you see there, that graph that you see with the bars, it's representing how much money pet owners spend on their pets. And that's in millions of dollars. So in the year 2001, it was at 29 million. Oh, actually billions. That's crazy. So by the year 2007, that had increased to 41, right? So we could also see that according to this source, the American Pet Products Manufacturers Association, there was a constant increase of 2 billion. So imagine, because of that, we could call it also a arithmetic sequence. So you add 2 billion every year. And if you connect those bars, you could see a line, right? All right, now let's see. So now, if you see the numbers listed here by commas, what is the difference from the first and the second term? 2, right? And then what is the difference between the second and the third term? 2 again, and same applies, right? So for all of them, it's going to be a plus 2. So in that case, that constant amount, which is 2, is what we're going to call the common ratio. I'm sorry, common difference. Ratios for next section. All right, so that common difference, so please highlight that, is the difference between consecutive terms. That common difference could be positive or it could be negative, and that's okay. Also, we're going to refer to an arithmetic sequence. So here, write the following definition. Is a linear function whose domain is the set of positive integers. Okay. like a discrete function. And then let's just go over the definition inside the box. So an arithmetic sequence in which is a sequence in which each term after the first differs the preceding term by the constant amount. And we already talked about that. That is called the common difference. So we're going to use the letter D for difference. Okay. So now in this case, for example 1, we're going to write some of the terms, the first 6 terms, and we are given the first term. So a sub 1 is 6. Now, according to this formula here, to get the second term, we will need to have the first term, right? The one right before. That's why we have n minus 1 for the subscript. And then we will subtract 2. Now, to find the third term, we will need the second term and then subtract 2, right? So what type of sequence does this remind you of, besides the fact that it is arithmetic?
The summation.
Say that?
The summation or not?
Summation, well, if we add them, yes. But think about the one that you needed the term before to get the next. Factorial? Say that again? Factorial, well, factorial, we need the term before, yes, it's true. So that could be a type of. Starts with an R. Recursive, yes. And they're used in computer science a lot. So in this case, we will need, for a sub 2, we will need the first term, right, which is 6, and then we subtract 2. So that will be, what is that? 4. And then for a sub 3, we will need 4, and then subtract 2. That gives us 2. Now, go ahead and find all the way to 6, to a sub 6. Okay, so you can see here that the common difference was that minus 2, right? So to go from, actually, let me go back. Let's see, to go from it's all minus 2. To go from one to the other, minus 2, minus 2. So to go from the first to the second term, you subtract the common difference one time, right? But to go from the first to the third term, we could say that you subtract the common difference how many times? Twice. And then to go from the first to the fourth,
Thrice.
you do another here minus 2, right? So then in total, you're doing minus 2 3 times. So what's the relationship between the number of times that you subtract the difference with the subscript?
1.
It's minus 1.
A minus 1, right? So you consider the subscript. If you need the, let's say, 12 term, how many times would you subtract the difference? 11, right? 1 less. And I say subtract, but sometimes it might just be add. So let's go to the next slide. And so that is the same thing that we have here. So to get the second term, you subtract the difference once. To get the third term, well, in this case you add, sorry. You add your difference twice. To get the fourth, three times. To get the fifth, you subtract 4 or add 4. To get the sixth, you do it 5 times. And so because of that, instead of me telling you, okay, I want you to find the first 10, or let's say I want to find only the 8th term of a sequence. So instead of going like A1, A2, A3, like one by one, then you substitute into the formula here. Okay? So where does that formula come from? So it doesn't matter what term you want. Let's say you want the 8th term. So you are always going to need the first one. So the first term is very important. And then how many times are we going to add the common difference? 9. 7. So it's 8 minus 1. So it's 7. So it's going to be 8 sub 8. It's going to become a sub 1 plus 7 times the common difference. Okay, and see, do we have the first term?
Negative. Oh, no, 4.
So find the eighth term of an arithmetic sequence whose first term is 4. So we have a sub 1 is 4. And then it says here the common difference is negative 7. So D is negative 7. So if we go here and we substitute, so a sub 8 is going to be 4 plus 7 times the common difference, which is negative 7. So 4 minus 49, so that is negative 45. So that one right there is the eighth term. Okay.
You miss it's Jeremy, is that me? I was just.
Let's go to questions? Questions? Anyone who's still writing? Let me know, Sarah.
I'm ready.
Okay. And so, you know, with that formula, you could find any term. Let's ask you, find the 100th term. That's easy, right? You just need the first term, and then you're going to add the common difference. How many times? 99. Exactly. Right? That is one of the formulas that you need to memorize for the exam. Is this section going to be in the exam? Yes, unfortunately. The good news is that it's very easy, so it should balance out your the other ones that you might not be as comfortable with. Okay, so next problem. So, may I have a volunteer to read it, please?
For card?
Andrew, thank you.
No, for card. The graph in figure 10.4 shows the percentage of the U.S. population by race/ethnicity for 2010 with projections by the U.S. Census Bureau for 2050. The data show that in 2010, 64% of the U.S. population was white. On average, this is projected to decrease by approximately 0.45% percent per year.
Okay, that's it.
Is that all? You want me to read it, or you want me to read A and B?
Yeah, read A and B.
Write a formula for the nth term of the arithmetic sequence that describes the percentage of the U.S. population that will be white in the years after 2009, and what percentage of the U.S. population is projected to be white in 2030.
Okay, so let me see if you guys understand what the problem is saying first. So, this was according to the 2010 census. When is the next census going to happen? 2020. So pretty soon, right? It's going to be very interesting. I can't wait to see those numbers.
Like next year.
And so I can tell you one thing that is going to happen for sure by 2050. There's going to be more plastic in the ocean than fish. Yes, it's true. Okay? And if you don't believe me, you should do a little bit of research so you can actually see that it is true. Okay? So what's happening here is that the way they define white is white people who are not of any other minority. Yes? Do you guys understand me? Because, for example, the Latino population, they are still within the white race. Most of them. But then there's the ethnicity, you check Hispanic or not. Yes? Is that clear? So this is like non-minority white people. So then when that was taken, out of 100%, the total population of the US, 64% were white. And here we're not really working with what was the total population. We're just working with the percentage, okay? So then we're going to say that A sub 1 was just 64, or 64%. And then D, which is the common difference, and because it says decrease, we're going to say negative 0.45. Why is it negative 0.45? Because it's 0.45%, so it is decreasing, yes. So we don't need to like move the decimal point, we don't need to do anything, we just take those numbers like that. Okay, now you can see that based on that, the projection for 2050, that will be what's in the yellow bar, will go from 64 down to 46%. These are just percentage, don't think of millions or billions. Then what's happening to the Latino population? It's increasing, right? Growing. And perhaps because they have more children, right? Instead of having one, they have 2 or 3 or more, right? Now, same here, this one is increasing not as fast as the Latino population for the African American population, and same with Asian. And this is like kind of interesting because this is like applies to Asians in the U.S. But if you look at other countries, and I'm sure like Holtzman loves to talk about this, and he covered this with you guys in human geography. But yes, Asian population in certain countries is decreasing, and other ones is increasing. So then with the U.S., it is increasing. Now, remember, these are just percentages, right? So if we were to add all the percentages for the purple graphs, what should they add up to? 100, right? Same thing with the yellow graphs? Do they? I haven't really checked, so I'm hoping. By the way, that is true information from the Census Bureau.
Wait a minute. No.
Okay. All right, so we're going to write a formula to describe that arithmetic sequence, and then we're going to consider the year 2009 will be n equals 0. So then the year 2010 is going to be n equals 1, a year after 2009. And how do I know that? Well, because the problem says n years after 2009. So that establishes that 2009 is n equals 0. So from here, for the year 2030, I'm getting a little ahead because we're going to have to find that one. 2030, what are we going to say that n equals to? To what? 20 or 21? 21. So if you notice, there are 10 years difference here. So if you add 1 plus 10, I'm sorry, not 10, but 20. 1 plus 20, you get 21. Okay, so now let's answer part A first, which is come up with the general formula. So to find any term, we need the first term, and then we're going to add n minus 1 times the common difference. So in this case, for any term, we'll need the first term, which is a 64, plus n minus 1, the common difference, which is negative 0.45. So then we can use that formula. This is a valid answer. However, if you simplify it, and I'm going to do that so you can see how it is a linear function. So I'm going to distribute that negative 0.45 with the n, so negative 0.45n, and then negative times negative is positive, so positive 0.45. And from there, a sub n will be 64.45 if I combine like terms, such as that and that, the constants. And then we will have minus 0.45 times n. So that one looks more like a linear function, right? So think of that as the slope, the constant rate of change. Mx plus b, yeah, as we put it in, y equals, this will be like a b plus mx, which is the same, right?
Yeah.
Because addition is commutative. And so this will be like the y-intercept. Okay. Now let's go. So that's the answer for part A. Now let's answer part B. So for part B, we're going to be finding the term, the 21st term, which will correspond to the year 2030. So then you may use this formula here, or this one. It doesn't matter. They are the same. So I'm going to use the second one for now. So 64.45 minus 0.45 times 21. Okay, so if you don't have a calculator, please get one. This is a good time for you to stretch. So the answer should be 55. 55, remember we're talking about percentages, right? So this was for the year 2030. The one that we had a prediction for was 46. So somewhere in between here, I guess we could put another line like that, and that would be like the 55%. So this was for the one in purple is for the year 2010, and then here 55% for the year 2030, and then 46% for the year 2050. It is also projected, just so you know how useful math could be, that by the year 2030, the state of Texas, which has been a red state for the past, I don't know, forever, well, not forever, for a very long time, it's going to turn blue.
Green.
Blue because of the minorities tending to vote more Democrat than Republican. Okay? Yes? So, we cannot do the projection for the other races because we don't really know what was the ratio change. Well, maybe we could actually, but I don't want to do it right now. All right, so let's go to the next slide. And then let's write that definition before you guys go to your break. So we're using n to generalize, so it will be the sum of the first n terms. So if we have something like s sub 4, we're going to be adding the first 4 terms. But of course, if we don't know how many we're talking about, we use n. Of course, that will be determined before you add the answer the question. The first n terms of an arithmetic sequence and it's going to be denoted by capital S for sum and then the subscript n. So if we want the first 4 terms, we put S sub 4. If we want the first 100 terms, we'll put S sub 100. Okay, so I'm gonna pause so you guys can go on break, and then when you come back, I'm gonna tell you a very interesting story. Okay, so make sure you do have that definition written, and what I'm gonna do now is show you where the formula to add to obtain a partial sum of a sequence, where the formula came from. So it was actually created by a 4th grader back in the day, and you guys know a little bit about him. And so let's see if you guys remember his name. Carl Frederick Einstein.
Oh.
You guys remember that guy?
Yeah.
From where?
From matrices, right?
Yeah. So he's the one who created the Gaussian elimination, and then along with the other guy with last name Jordan, they created the Gauss-Jordan, right? Let's put that one away before I take it from you. Okay, so then he was in 4th grade, and of course he was like this super smart kid. Sometimes the teachers didn't know what to do with him because he was so smart, and so sometimes the teachers will probably think he was a little bit of a bad kid. So the teacher used to get frustrated and give him a lot of work. The story says, right? I don't know if it's true. to like busy work, to keep him busy.
Oh, I know this.
And so she told him that she wanted him to add all the numbers from 1 to 100. And she was hoping that he was gonna be occupied for a few hours, right? Well then, how long do you guys think it took him?
5 minutes.
I don't know exactly how many minutes, but this is what he did, okay?
It's 5 minutes.
So pay attention, this is the process, and you can understand that because I showed this to my son like a long time ago and he knows it. So if you line up all the numbers, right? 1 plus 2 plus 3 plus 4, and then we're just gonna use that to express that there are some terms in between, right? But they're going one by one. So then the last terms, I'm gonna say 97, 98, 99, and then plus 100. So he did that, he wrote them all down. And then he thought about writing them again, but in reverse. So 1 plus 2 plus 3 plus 4. And then of course at the end will be like the last step, so like 100, 99, 98, and 97. Okay. So then if you add the first and the last term, what do you get? 101. What about 299?
101.
101. And you will get that, you will keep getting that, 101, 101. Right, 94 and, I'm sorry, 97 and 4. 98 and 3. And of course here, 101. So if you think about it, how many 101s do you have in total?
100.
So you have 100
So
times 101,
so
right?
you would have 10,100.
But how many times did you write the sequence? Twice. So then we have twice as much, right? So then we need to divide by 2. Exactly. And so that's how he found the first 100. So going back to the sum. So if the 101, we could say that it came from adding any two terms that were in the same column, right? But we could also just say that it came from adding the first term and, in this case, the last term. Why do we know that's the last? Because it was the subscript, right? And so that's where that formula with the n over 2, so here 100 over 2, and then you add the first and the last term. So that's how you obtain it. You will see this in Cal 2. So make sure you remember the name, the sum of the first of the arithmetic sequence. The terms of an arithmetic sequence. If you answer that question in Cal 2, your calculus professor might like you a little bit more. Okay, so now let's go ahead and apply it. So if we look at those numbers, 1, 3, 5, 7, what do you guys think will be the next? 9, right? So to me, it looks like the first 100 terms, first 100 what? Odd numbers. Very good. So then, according to the formula, to add the first 100, we're still going to use the same. Well, I'm going to write it in general terms first because you do have to memorize it as well. So S sub n will be n over 2, right? Like the 100 over 2, remember? And then we add the first term plus the last term. So in this case, to find the 100, the sum of the first 100 odd numbers, we will still need 100 here and then divided by 2. However, we know the first term because it's given to us. It's right here. So we know that a sub 1 is 1. But we do not know, at this time, we do not know a sub n, which is going to be the a sub 100, right? So we need to find, what else do we know by looking at the sequence? The common difference is 2. Positive or negative? So positive 2. Now, with this formula, what I need is the 100 term. So that is the first thing we will have to do. So find the 100th term. So for that, we're going to call that formula from the like 2 or 3 slides ago that says any term can be found by using the first plus the common difference added how many times? 1 less than n. So how do we say 1 less? N minus 1. Okay? So that's what we're going to use. So to find the 100th term, we will use the first one, which is equal to 1, plus how many times? 100 minus 1 is 99, times the common difference, which is positive 2. And so the 100th term will be 1 plus 198, which is 199. So then right here, I'm going to just say, I'm going to use a sub 1 here. Like the variable. Okay. So then we go from that to a sub 100 will be 100 over 2, which is 50, times a sub 1 was the number 1, and then a sub 100 was 199. So this is 50 times 200,
10,000.
which is 5 times 2 is 10. And then how many zeros? 1, 2, 3. 1, 2, 3. Like that. Pretty easy, right?
Yes.
Okay, so now I'm going to just tell you the steps you need to take, and I want you guys to practice finding that. So in this case, we need to find the sum of the first 100th term. So number 1, find
That's the first 15 terms.
15, yes, 15, sorry. So find a sub 1, which is given to you, right? Not too hard. Second, find d. How can you find d? Well, you could take a sub 2 and subtract a sub 1. So you will get 6 minus 3, which is 3. You could also, just to check, take the third one, subtract the second one, and see if you get the same. So 9 minus 6 is also 3. So then the first term given to us is right here. It is also 3. So now we have that. What should be our third step? We have the first term and the common difference. So we use the formula to find the nth term. We use that to find what? So if we want to add the first 15 terms, we need the first and the last. So which term are we looking for? The last one. Not the one before the last one, the last one. So the last one will be a sub 15. So that's going to come from adding the first plus how many times the common difference? 1 less, Trisha? 14. So then just go ahead and find that. So a sub 15 is going to be a sub 1, which is 3, plus the common difference 14 times. Do you guys have a question? Don't be afraid to ask. Tell me. Should I go up? Are you sure? Okay. So then we do that. So we're going to have 3 plus 42. So that is 45. Oh, that's an equal. 3 plus 42, so it is 45. Okay, number 4, you're going to use the formula S sub n is n over 2 times the first term plus the last term. Do we have the first term? Yes. Do we have the last term? Yes. That's all we need. And how many are we adding? The first 15. So that will be 15 over 2 times a sub 1 was 3, and then a sub n, the 15 term was 45. So that will be 7.5 times 48. 360? And that was like the first 15 multiples of 3, right? You guys notice? 3, 6, 9. Okay, now those are very complicated. Yes. We can't do it. No, I'm just kidding. So, if you were here last class, I think I showed you a little bit of how to put it on the calculator, so let's just review it again. Okay, so if you don't have a calculator, please get one. Right now, mandatory, all of you. And so I'm going to switch the window to the calculator. Okay, so first thing we need to do is go to the calculate portion of our calculator. So, not the graphing one. And then once you're there, you are going to use the menu function. And then, just in case you don't remember where the factorial is, it's under probability. We're not using factorial today, but I want to remind you. You can see it here. And then the other ones that you see here, permutations, combinations, we're actually going to be using them in the next sections from 10.5 through 10.7, which will be the last one from chapter 10. Okay, so today what I want you guys to use is the calculus function. So again, you go to menu, calculus, which is 4. And then we're going to use the number 5 for sum. And so you can enter there the numbers just like your paper. Now, things to consider. If you are going to use the letter I here, make sure that you also, what is the first one on your problem? How do we call that number that goes below the sigma? Limit. Yes, lower limit. And the one above the sigma? Upper limit. Okay, so what is the lower limit? Yeah. What number is it? 1. 1? Okay. Remember, that could also be a 0, right? Don't be scared if that happens. Or it could be a number other than 1. What is the upper limit for that one? 25. 25. So we want the first 25 terms, right? 25 terms. And then what is the formula in there? 5. So look, just, I'm going to use another letter. I'm going to put 5x. Minus 1? 9? No, it doesn't work. So you have to use the same exact variable. So what letter am I supposed to use instead of x? I. So you should get 14. So go ahead and practice the next one, and then compare with your neighbor. See if you get the same. You don't need a neighbor.
I'm glad I don't have it. Yeah. My last name.
Okay, so I'm going to do it again in case you were not paying attention. So menu, calculus, and then sum. You could use other letter too. I wouldn't.
6 and minus 6.
So you guys see how I'm using n as my variable? I need your attention, please. So as long as I have n here for my lower limit and also inside my formula, this will work.
No, it's 11, not 1.
What do you mean? Oh, here?
No. Up there.
11. Oh, okay. Oh.
It works, miss. If you use a word, it works. At least prove it next year.
Wow, look at you. Great use of technology. Yes, you could, just like in computer science, you could call your variables whatever you want, except for reserved words that already have a meaning. No numbers. Okay, so that's the correct answer? Yes?
Yeah.
2,460. Okay, let's move on. You guys, you too, you need to stop. Okay? I already separate you. I'm not asking you. I'm just telling you to stop. Uh, 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 I'm looking at you. Okay, last question. Let's get through it without talking. Well, you guys. Don't look at each other either. Don't look at Carla. Okay, so last problem is just the one about the guano, right? Going into an nursing home. And just like I told you, it was pretty expensive. So let's see if she's gonna have enough money to pay for that. So I don't know why she's only concerned about that 6-year period, but we're gonna find the sum of the first 6 years of her living there. So we're going to need, of course, the number of terms, which is 6, and I'm using this formula. I suggest you write it down every time you use it, that way it can stay in your head. So we need the number of terms divided by 2, and then we're going to add the first term plus the last term. Oh, in this case will be the 6th term. Okay, now do we know the first term? I don't think so, but do we have a formula for it? Yes, we have it already here. And so that is already the one that we use with the a sub n is like the first one plus the common difference n minus 1 times. Is that one, but already in simplified form. So it looks more like a linear function, right? 1800 is like your slope, the constant rate of change, because that's the increase per year. And then the 64, 130 is what it was at the beginning. So then we're going to say, you guys notice how it says here n years after 2013? So that's my clue that 2013 will be n equals 0. So then 2014 will be n equals 1. Okay? And so we're going to find first, let's find the first term. And then second, we're going to need the last term, which will be the 6th term. Okay, and so if you already have a formula, just go ahead and use it. So you will be substituting here a 1 and then a 6. So the first one will be 1800 times 1 plus 64 1/3. So then here for the 6, we'll have 1800 times 6 plus 64 1/3. Okay, so does anyone have the first or the 6th?
I got, for A6, I got 74,930.
Very good. So what year would that be, A sub 6? So what's the difference from 1 to 6? So plus 5, right? So 2014 plus 5? 2019. So we're talking about year 19. Okay, what about A sub 1? Who found A sub 1?
65,930.
65 what?
65,930.
Thank you. Okay, so now we're going to use those over here. So for A sub 1, we have that 65,930. For A sub 6, the last one that we're considering is 74,930. And why are we multiplying by 3 and not 6?
Because you divide the 6 by 2.
Mm-hmm. So we're following that formula, right? N over 2. Okay, and I do not want Andrew to give me that answer.
I have the answer.
None of the Andrews in this class. So, okay, Ted.
450,000.
450,
422.
422, 580. Okay, so does grandma have enough? How much she had at the beginning? 500,000. What she have for an extra year though? How can we get the next year? How much it will cost? Try doing that. 74,930 plus 1,800. Tell me quickly.
Isn't it just 65,930? Because you. Oh no, wait. So never mind.
So the seventh year is 76. What?
730.
500.
No, 730.
730. Okay. So do me a favor then. Add that plus this. The cost for the first 6 years.
499,310.
Oh wow. So she might have for an extra for a 7th year, right? But not for an 8th one. Definitely. So now I promise you I was gonna give you a better option, right? So I watched this. I don't remember if it was a news or what. About this lady who, instead of living in a nursing home, she just goes on a cruise after cruise after cruise, because it is cheaper for her to pay for the cruise. She gets like a nicer room. She gets food made for her, and there's a nurse and a doctor on board, so she doesn't have to worry about it. Because if you're a cruise passenger, that's included because you get sick.
Wow, that's cool. I
So
wanna
she
do
gets
that when I.
medical care. She travels around the world, and she gets spoiled in the cruise. And of course, people know her, and then also she accumulates points, so she ends up buying the price, a discounted price. Gets to go in like first class and all of this. Cheaper than a nursing home. So like seriously, I'm considering.
Until when?
Until when? What did
Yeah,
until
until
she
she
dies?
dies.
Until she dies. She would rather do that.
She falls up.
Wait, has she died yet?
I don't know.
What happens if the
We
money,
should look it up.
what happens if the money was out for?
Okay, this is the end of the video.